Lesson 10.3 is about arcs and chords. We talked about what an arc and a chord is in the last two sections. So now we're going to be getting into some theorems and possibly some proofs proving different aspects about them. Theorem 10.2 basically says, in our picture, if FG, that chord, is congruent to HJ, and I'm going to use my highlighter just so you can see what I'm talking about. If FG is congruent to HJ, then, or we have this if and only if, we can abbreviate that by putting if with two F's, if and only if. If their corresponding arcs are congruent, which is the arc FG would then be congruent to the arc HJ. Theorem 10.3 is talking about the diameter. Okay, so you need to be able to define that AB is a diameter. And then what it's saying is that not only is it diameter, but it is perpendicular to a chord. So AB would have to be perpendicular to the chord XY. If that is true, then we could say that XZ is congruent to ZY. We could say that these two are congruent. And we could also say that our arc AB, I'm sorry, not AB, arc XB is congruent to arc BY. So if those two chords are congruent, then these two arcs are congruent by Theorem 1.3. Now, sort of similar to that is Theorem 10.4. If the perpendicular bisector of a chord is the diameter of a radius or a circle. What this means is if AB is a perpendicular bisector of XY, then AB is the diameter of circle C. So it's kind of proving backwards. In the 10.3, we had the diameter and we proved something about the chords in the arcs. In 10.4, we know that it's a perpendicular bisector, therefore we're proving a diameter. In 10.5, our last theorem of this section, here we're talking about chords and their distance from the center. So if, let's say, angle X is congruent to angle Y, if this is true if and only if, there's our funny way of spelling if and only if FG is congruent to JH. In other words, FG and JH, those are congruent if these are equidistant, if the distance from LX and LY are congruent. Okay? We're going to apply that with some of our examples. So example 1. This has to do with Theorem 10.2, which talks about if our pieces of our chords are congruent, then our arcs are congruent. So if these chords are congruent, and they are, then the measures are congruent. So the measure of arc KL is congruent to the measure of arc JM because of Theorem 10.2. Because of that, since we know that KL equals 90, JM is also going to equal 90. Alright, in example 2, here we have two circles that are both congruent, and we know that these two chords are also congruent. Find WX, and Miss Holbert forgot to make an X. I made it a Y instead. Since we know that they are congruent, let's set these two chord measurements equal to each other and find X. So minus 5X from both sides, add 2 to both sides, we get 2X equals 8. X equals 4. Is that what we needed to know? No, we want to find the length of WX. So let's plug it in. 7 times 4 minus 2. So 28 minus 2. WX is 26. Very good. Alright, example 3. Here we're going to apply Theorem 10.3. Okay? We need to know how big arc DE is. This arc right here, I'll highlight it so you can see it, arc DE. We know that DEF is 150. This whole thing is 150. Well, this is bisecting this, and so since this little piece DE is half of it, arc DE is going to equal half of 150, which is 75. Now on example 5, the picture, I forgot to wrap the text. So this behind it says, and chord EF is 8 inches. You are going to find CD. Okay? So I know that the diameter, so from A to B, is 18. And I know that EF, this whole long piece, is 8. Find CD. I just want to find that little piece here. So if I sort of draw this square, pretend that's a square. Here's D, C, F, and E. I want to find this piece right here. Okay, I know that EF is 8, so since AB is a diameter, I know that each of these pieces, ED and DF, is 4. Okay, since the diameter is 18, I know that the radius, or from C to E, the radius right here, radius is half the diameter, so the radius is 9. Hey, I kind of have a right triangle. If I were to draw this out, just the triangle, I have this picture right here. I want to find CD. I could use Pythagorean theorem to find this. X squared plus 4 squared equals 9 squared. Okay, let's simplify. And let's solve for x squared. Okay, so CD is the square root of 65, which if you put that in your calculator is about 8.06 inches. That's the length of CD. So on some of these pictures, you are going to have to literally pull it apart and break it down. We had a circle and then a square inscribed in it, and it really helped me to draw just the square and then break it down into familiar things like a triangle. And then from there, I can use Pythagorean theorem. So if you get stuck, think about how you could break some of these shapes down. Okay, last example, which is example 5, part 2. We know that in circle P, EF equals GH. So EF and GH are congruent. These two right here. Those two chords are equal, which means they are equidistant from the center, because this is theorem 10.5. Because they're equidistant, that means PQ and PR are also equal. Since those two are equal, let's set our equations equal to each other. 4x minus 3 equals 2x plus 3. Let's solve for x. Minus 2x plus 3. We get 2x equals 6. Divided by 2. X equals 3. And is that what I needed to know? No, I want to find PQ. So let's substitute in PQ. That's 4x minus 3. So 4 times 3 minus 3. PQ is 9. Excellent. See you next time on lesson 10-4.